In today's rapidly evolving world of artificial intelligence, traditional data centers struggles to keep pace with the demanding needs of AI workload. These workloads require significant resources, including processing power, storage, and network bandwidth. In this presentation, we will explore how software-defined data center can provide a dynamic and adaptable foundation to support this demanding AI application. We will discuss the core concept of software-defined data center, its benefits for AI workload, and how it can empower organizations to develop and deploy innovative AI solutions faster. Traditional data centers were designed for a different era of computing. They often suffer from soiled resources, limited scalability, a lack of automation, and slow deployment cycle. These limitations can significantly hinder the development and deployment of AI application. For instance, if an AI model require more processing power during the training, scaling up resources in a traditional data center can be a slow and manual process. Similarly, provisioning a new resources for AI development can take days or even weeks. Let's look at the different component of software-defined data center. A traditional data center often struggles to keep up with the ever-changing demand of modern applications, especially those involving AI. Those applications require a lot of processing power, storage, and network bandwidth, but traditional data centers often have these resources soiled and difficult to manage. This is where software-defined data center SDDC come into play. An software-defined data center virtualize these hardware resources using software, making them more flexible and adaptable. Here is how it broken down. Virtualization. Imagine a layer of software called a hypervisor sitting on top of your physical server. This hypervisor act like a conductor, abstracting the hardware resources like a CPU, memory, and storage. Think of abstraction as hiding a complex inner working and presenting a simpler interface. With virtualization, you can create multiple virtual machine VM on a single physical server. Also, a container with multiple container in a physical server. Each VM acts like a standalone computer with its own operating system and resources, even though they are the underlying hardware is the one server. This allows the better resource utilization and easier management. Software-defined networking (SDN). In traditional data center, physical network devices like switches and routers control how data flows. SDN changes this by putting software in charge. This software layer allows for creating logical network on top of the physical infrastructure. Imagine this logical network as virtual pathways designed for specific application. They can be dynamically provisioned, created quickly, and reconfigured to meet the specific need of your application, offering a greater flexibility and control over the network traffic. Software-defined storage. Storage resources from various physical storage devices like hard drives and solid-state drives are often scattered and difficult to manage. SDS bring these resources together. It pulls storage from various devices and manage them with the software. This creates a single virtual storage pool that can be dynamically allocated to VMs and applications based on their needs. Think of it having a one big pool of storage that can be easily accessed and distributed as needed. By combining these elements of software-defined data center provides a more agile and scalable foundation for data center, making them better suited for the demanding needs for AI workloads. One of the most significant benefits of the software-defined data center for AI workload is its agility and scalability. Traditionally, data centers are often inflexible and struggle to adapt to changing resources needs. Software-defined data center, on the other hand, allow you to scale resources up or down on demand. This is essentially for an AI workload, which can experience significant fluctuation in the resource requirement during training and inference phases. For instance, during the training phase of a complex AI model, you may need a large number of GPU to accelerate the training process. With the software-defined data center, you can easily provision the necessary GPU and then scale once the training is complete. This on-demand provisioning helps to optimize resource utilization and reduce cost. Software-defined data center offer a new approach to data center management. By virtualizing physical resources and automating tasks, software-defined data center provide a more agile and scalable foundation for AI workload. With a software-defined data center, resources like a CPU, memory, and storage network bandwidth can be pooled and dynamically allocated to AI workload based on their needs. This eliminates soiled resources and optimize resource utilization. Additionally, software-defined data center automate many data center tasks such as VM provisioning and network configuration. This streamlined workflows reduce the manual errors and allow for faster deployment. Finally, software-defined data center often provide a self-service portal where developer and data scientists can request resources on demand, accelerate deployment cycles, and fostering innovation. So let's look at the software-defined data center spine leaf architecture, and different component and how the architecture works. The spine leaf architecture is a common network design choice for software-defined data center due to its scalability and high performance, and also consistency and easy expansion. In this architecture, spine switches provide the high bandwidth core network, providing connectivity between leaf switches. The leaf switches, these connect directly to the servers and provide access to the network. The layered approach facilitates efficient data flow and simplify network management, making it ideal for the demanding workload for AI applications. Overall, a software-defined data center with the spine leaf architecture provide a dynamic, scalable, and adaptable foundation for supporting evolving applications like AI. It empowers organizations to efficiently manage resources, optimize performance, and accelerate innovation in the ever-changing world of AI. Software-defined data center, when combined with the containerization technologies like a Docker and container orchestration tool like Kubernetes, empowers a cloud-native approach for AI development and deployment. A cloud-native approach emphasizes building modular AI applications using containerized and managing them with a container orchestration tool. This approach offers several advantages for AI workload. First, it promotes a microservice architecture where AI applications are broken down into smaller independent services. This makes them easier to develop, maintain, and scale. Second, containerization ensures consistent behavior of AI workload across different environments, whether on premises or in cloud or a hybrid environment. Third, Kubernetes enable elastic scaling of containerized AI workload, including GPU resources. This means that resources can be automatically scaled up or down based on the demands of the workload, optimizing resource utilization and reducing costs. Finally, containerization streamlined the CI/CD pipeline for AI application, enabling faster deployment and update. So in conclusion, software-defined data center offer a powerful and adaptable foundation for supporting the demanding needs for evolving workload. A software-defined data center virtualize the physical resources, automate tasks, provide a self-service module for resource provisioning. This leads several benefits for AI workload, including improved resource utilization, on-demand scaling, and faster deployment cycle. Additionally, software-defined data center can be leveraged to embrace a cloud-native approach for AI development and deployment. This approach foster modularity, portability, and elastic scaling of AI workload. By adopting a software-defined data center foundation for the AI infrastructure, you can empower your organization to develop and deploy innovative AI solutions faster, gain a competitive advantage, and unlock the unlimited capabilities of the AI future. So the world of AI is constantly evolving, and traditional data centers are struggling to keep up in space. Software-defined data centers offer a dynamic and adaptable solution that can address the challenge of AI workload. With the software-defined data center, you can achieve on-demand scaling, improved resource utilization, and faster deployment cycle. Now is the time to take action, explore a software solution and cloud-native technology to see how they can benefit your organization. Unlock the potential of AI and build a future-proof foundation of AI innovation. Thank you for time today. I hope you have found the presentation informative. Please don't hesitate to reach out if you have any question. Thank you.